Good evening. Our topic for today is a continuation from what we began last week when we looked at what is material science and the type of materials that we have. So we looked at the classification of materials, and we looked at each and every type of material. So today we continue with looking at the atomic structure and the interatomic bonds. So as we talked about, as we discussed last week, we say the type of material, the properties of the material are dependent on their atomic structure as well as the type of bonds. Okay, so have you ever wondered what is nanotechnology? I'm sure this term is not new to many of you. It's a quite commonly used terminology, especially in the recent years. Another question is, why is it that carbon in the form of diamonds is one of the hardest materials known to man, whereas graphite, which is also a form of carbon, is very soft and can be used as a solid lubricant? Why the difference? Another question is, how is silica or sand, which forms silica, which forms the main chemical in big sand, used in an ultra pure form to make optical fibers? How is it that one material can have quite a number of different applications or different properties? What makes a material have more or less like a range, okay, of properties? So we'll look at these questions and we'll try and answer them. So to characterize the structure of materials at various length scales, we use the atomic structure, the short and long range atomic arrangements, and the nanostructure, the microstructure, and the macrostructure. So we're going to try and go through each and every one of these just briefly for you to have an understanding of what is being talked about. Okay. So we begin with the atomic structure. Atoms are, I think the word atom is a word that we use quite often, especially in our high school. We look at the definition, what's its composition, and the applications also. Atoms are made up of protons, neutrons, and electrons, which are responsible for the mass and change of atoms, and the charge, of atoms. So a nucleus consists of protons and neutrons, and the electrons surround the nucleus. So we're going to understand how atomic structure affects the properties and behaviors of different materials. We're going to look at the structure of how the structure of atoms affects the type of bonds that hold the materials together. Okay, so we know that the structure of atoms affects the type of bonds, and that the diameter of atoms typically is measured using the angstrom unit. So we come to the short and the long range atomic arrangements. So on the left here, we have a picture of the crystalline arrangements. And on the right here, we have a picture of the amorphous arrangements. So the crystalline arrangement is referred to as a long range order. Okay, long range order. So this can repeat, over and over and over again. You have centimeters of the same arrangement in the same perfect order, repeating itself. Whereas in the amorphous or the short range order, you find that they just order probably just around here later. As you go, the pattern is not maintained in short. So we begin here with the long range order. The atoms are well arranged, as you can see in this picture. Okay, there's a pattern. So the greens are there, the reds are there. So these are different atoms. There's one belonging to another material, maybe this is another one here. So there's a pattern on all sides. You can see consistency in the pattern. The second one is the atoms or ions arranged in a three-dimensional pattern that repeats over much larger distances. Unfortunately, this one is a 2D picture, but then as we go, you get to see a 3D picture of basically the same thing. Okay, so the pattern repeats over much larger distances, that is from around 10 microns to a centimeter. An example of such an arrangement is in metals. So we know that metals have their atoms arranged in an orderly manner. Okay, that is one of the reasons that makes atoms that makes metals much stronger than other materials. We come to the short range order of the amorphous. Atoms are arranged at random, as you can see in this picture. Okay. What else do we see? The atoms or ions show a particular order only over relatively short distances, from 1 to about 10 angstrom. An example here that we can have of this one is glass. Of course, this arrangement reminds us more of the Brownian motion, also that is found in gases. Okay, so we come to nanostructure. Material science and engineering is at the forefront of nanoscience and nanotechnology. So what is nanoscience? Nanotechnology, nanoscience. We'll look at nanoscience first. This is the study of materials at the nanometer length scale. Okay, so what is the nanometer length scale? We'll look at that also. But before that, we look at what nanotechnology is. So nanotechnology is the manipulation and development of devices at the nanometer length scale. The nanostructure is the structure of a material at the length scale of 1 to 100 microns. So that is about 10 to the power minus 9. Okay, that is what makes up a nanometer. So as you can see here, you are actually studying materials at a very, very, very expanded range, okay? A very much zoomed out range, almost to a point where you basically cannot see it. So that is the range at which, or the length scale at which materials are studied in nanotechnology. Okay, that is from 1 to about 100 microns. So the microstructure, so we move from nano to micro. What is microstructure? This is the structure of materials at a length scale of hundreds to 100,000 microns, or 0.1 to 100 micrometers. So we're going to look at the microstructure. When we say we're looking at the microstructure of a material, meaning we're looking at it if it were under a microscope. Under a microscope, we're going to have to expand our view up to around 100,000 microns, or 0.1 to 100 micrometers, in that range. That is what is known as a microstructure. So microstructures typically refer to features such as the grain size of a crystalline material and other related to defects in materials. So we're going to look more about, we're going to further study different types of microstructures of different metals or different materials, particularly metals. But for now, this is enough as just describe what exactly a microstructure is. An example of a microstructure is seen here. So it is basically a view under a microscope, and the view is about, the expansion is up to, the scale rather is up to 50 microns in this particular picture. So we look at microstructure. So if that is what microstructure is, then what is macrostructure? This is a structure of a material at a macroscopic level where the length scale is approximately 100 microns. I'll read that again. It's a the macrostructure is the structure of a material at a macroscopic level where the length scale is above 100 microns. The features that constitute macrostructure include porosity, surface coatings, internal and external microcracks, macroscopic level. Take note of that. This one was microstructure, and now we look at the macrostructure level. So for microstructure, it has a length scale of 100 to 100,000 microns. This one is above 100 microns. So we come to atomic structure and bonding. But before that, maybe a bit more about an atom. An atom is composed of two regions. We look at that partly. So we have the nucleus, which is in the center of the atom and consists of protons and neutrons. And then there's also the outer region of the atom, which holds the electrons in orbit around the nucleus. So let's take note of that as we come to interatomic bonding. So the objectives here that we have, the learning objectives are to learn about the structure of atoms, to learn about the bonding between atoms, how these form a foundation for the properties of materials. Okay. This will help us categorize materials as metals, semiconductors, ceramics, or polymers. Okay, so this knowledge will help us draw general conclusions concerning the mechanical properties and physical behaviors of these four classes of materials. So we have the four main classes of materials. Those are the metals, the semiconductors, ceramics, and the polymers. Okay, so what do we know about atoms? We know that matter is made of small particles called atoms. And been one of the major breakthroughs that we've had in science over the past years to understand an atom and later to be able to divide or cut through an atom. Those were one of the major breakthroughs that we had in science in the past centuries. So you have the atom there, which is composed of a nucleus. The nucleus is composed of protons and neutrons. And so the nucleus is also circled by moving electrons. So it's more like, reminds us more of how the solar system looks like. That's basically how an atom looks like. So electrons are negatively charged, whereas protons are positively charged. Then protons and neutrons have approximately the same mass, which is about 1.67 times 10 the power minus 24 grams, or what is known as 1 atomic mass unit, AMU, okay? Or it's also known as 1 Dalton. So electrons have a negative charge. I'm sure you know that already, while protons have a positive charge, while the neutrons are neutral, just by the name neutron. They are neither positive nor negatively charged. They have a zero charge. Okay, so all atoms, take note, all atoms at their normal state are electrically neutral. All atoms at their normal state, so meaning the electrons cancel the electron's charge cancels the proton's charge, giving it a zero charge, making them electrically neutral. So what do we know? What else do we know about atomic particles? They are infinitesimally small. as well as their masses. They are so small, almost as if they are infinitely small, but they are not infinitely small. What else do we know? Each chemical element from naturally occurring elements such as hydrogen to uranium is characterized by the number of protons in the nucleus, or simply the atomic number, okay, which is symbolized as Z. Okay. So the number of protons determine an element's atomic number, or the Z there. And this atomic number distinguishes one element from the other. There are no two elements that have the same. There are that, we're going to look at what are known as isotopes. Otherwise, each element has its own unique atomic number.